So for our second video here, we'll do example 4, where we're going to be solving equations. So we got an equals here already with a number on the other side. In order to solve logarithm equations, we again just change it to exponential form. So take the base, which is x, raise it to the second power. So remember that the log is equal to an exponent. So x raised to the second power is 25. So you can think, what does x have to be? And you might say a plus or minus 5, but because the square root of 25 would be plus or minus. But recall that when we define logarithms, we said the base had to be positive. So x has to be 5, not negative. Example B, I have x raised to the 2/3 power is equal to 4. So I need to decide what it is that's going to make that happen. So the first thing I'm going to do is, let's kind of separate this and think of it as the cube root of x squared is equal to 4. So let's raise both sides to the 3rd power and get x squared is going to be equal to 64. And then take the square root of both sides and get that x is equal to 8. So in this step right here, what I did was raise both sides to the 3rd power. Remember, those undo each other and bring that x squared out. And then 4 to the 3rd is 64. Example C, I have 1/4 raised to the 3rd power is equal to x. And so that's just 1/4 times 1/4 times 1/4, which is 1/64 is equal to x. Then D, 4 raised to the -2 is equal to x. So that's 1/4 squared, which is 1/16 is equal to x. All right, so here we have that a common logarithm has a base of 10. Back before calculators, they used to use logarithms to do arithmetic with big numbers, and a common logarithm was frequently used, and it has a base of 10. If a log has no base specified, it's understood to be a base of 10. So for example, 5, find the value of each logarithm. When I have a log but there's no base there, it's understood to be log base 10 of 1,000. And so then you get 10 to some power is equal to 1,000. So we're looking for that power there. And then that means that x is equal to 3. You can count those zeros. There's 1, 2, 3 zeros. So that's going to give me x is 3. And you can see now why that's a nice base to have of 10. Here I've got, again, it's log understood to be 10, base 10 of 1/10. So 10 to what power is equal to 1/10? Well, that flips, so it means that x is going to be a -1. In example 6, we're just going to be kind of investigating a couple of generalizations that are nice to be able to use. So here I have log base 2 of 16 is x. And so we would say 2 to what power is 16? Well, 2 to the 4th power is 16. I'm going to kind of rewrite this to emphasize this rule. 16 is actually 2 to the 4th power. So this basically says 2 to the x is equal to 2 to the 4th. And my answer then is that x is equal to 4. And then underneath it, I've got, again, this is 3. This is the log, log base 3. And then 1/9 is going to be 3. What's the power on it? It flipped it, so it's negative, and then it squares it. So log base 3 of 3 to the -2. So 3 raised to the -2 power gives me 1/9. And here's this rule that kind of emphasizes this. Notice on these, the base of my log and the base of my exponential expression are the same. They're both 2's here, they're both 3's here. And the answer comes out to be the exponent on those. So here's the rule. The log base b of b to the x is x. And then these others, this is not going to be quite as obvious. We haven't done them a bunch of times. But if you think about log base 2 of 16, so 2 to what power is 16? Well, 2 to the 4th power is 16. And that comes out to be 16. So 2 log base 2 of 16 is 16. And here we just found out that the log base 3 of negative 2 is negative 2. So we're going to say that this is 3 to the negative 2, which is 1/9. So again, this is really the main rule that we're going to be looking at here. If I have a base of b raised to the exponent that's a log, which is base b, these two things are inverses of each other and bring out the x. So log 4 raised to log base 4 of 5 is 5. 6 log base 6 of 2 is 2. Then 9 log base 9 of 3. I guess we could probably do that the same way. I think I would still just go ahead and do this where I'd say 9 to what power is 3. And then that's the square root, which means that x is going to be equal to 1/2. So I think what they were going for here is that you put this as 9 to the 1/2 right there. So 8 to what power is 2? Well, the cube root of 8 is 2. So that must mean that x is equal to 1/3 because that's the cube root of 8 is 2. So 32 to what power is 2? Well, that's the 5th root. So that means that x is going to be equal to 1/5. Here, this does not look like it's going to be quite as easy. We'll put that off and we'll do that next class. I won't make you do this. So this is going to be 7. And here, j is going to be, you can see those bases are the same, -3.